Here's an example of an enterprise campus architecture switch block. And we have our distribution layer, which is up here. And we have our access layer, which is down here. Let's go through the steps together that spanning tree protocol would go through to find the root bridge. Find the root ports, find the designated ports, and ultimately find the block ports in this typical enterprise campus architecture switch block. Let's do that together here. First one, find the root bridge. We know that to find the root bridge, we have to look at the bridge ID out of all the switches in this switch block. It's based on priority and MAC address. Priority being the first value that is looked at. So if I examine this topology, we have priority 28,672, 28,672, 32,768, 32,768. Well, we have a tie and we don't have a tie, meaning that switch A, B, C, and D are all tied. Or pardon me, no. Switch A and B are tied, switch C and D are tied, but switch A and B are lower than C and D. Therefore, we don't look at these switches anymore. We only compare these two now. So since switch A and B have the same priority, we look at the MAC addresses between the two. Starting from left, 00000C, all the same. And then I notice a difference here. A and 9. Which is lower, A or 9? Well, A is equal to 10 in hexadecimal. Or A in hexadecimal equals 10 in decimal. So when you compare it, you're looking at 0 through 9, then A, B, C, D, E, F in that order. Therefore, 9 is less than A, making this our root bridge. So switch B is our root bridge in this topology. Now let's examine this further, because we want to find the root ports now. And the root ports are going to be the ports on the non-root bridges, so switch A, C, and D, that are closest to the root bridge. And we have link speeds here, meaning that there will be costs associated with this. This is going to have a cost of 2. This is a cost of 4, cost of 4, cost of 4, and a cost of 4. So on switch A, which way is the shortest way to get to the root bridge? Is it this way, or is it this way? So there's 3 different ways to get there. Well, just by eyeballing it, you can see that if we go straight across between switch A and B, it's a cost of 2. If we go this way, we're dealing with a cost of 8. And if we go this way, we're dealing with a cost of 8. So definitely this is our root port. Root port. Let's examine switch C. If we look at switch C, if we go up and over, 6. If we go straight across, it's 4. 4 is less than 6. So here's our root port. Same thing with switch D. This would be 6. This is just 4. So our root port is here. Are we done finding root ports? Yes, we are. 1 root port per non-root bridge, and the root bridge can't have any root ports. We're done. So now we move on to the designated ports. And when it comes to the designated ports, we are looking at the segments, so the links. In this case, we have 1, 2, 3, 4, 5 different segments, meaning we will need to find 5 designated ports. And the designated ports are those ports on the segments with the lowest cost back to the root bridge. But let's execute our shortcuts. Every single port on the root bridge is going to be a designated port. So we can fill that in right now. Designated port, designated port, designated port. We're done on the root bridge. So we have 2 links left. This link here, which has neither a root port or a designated port. This link over here with neither a root port or a designated port either. So we need to figure out the designated ports here. Let's start off with this link. Position yourself in the middle of the link. If you go towards switch A and then across to the root bridge, what is the cost? 4 plus 2. 4 plus 2 is 6. If you go down to switch C and then up to switch B, 4 plus 4, that's 8. So we want to take the shorter way. So the shorter way is going through switch A, meaning that switch A has the designated port. Let's label that. Designated port right there. And this link now needs a designated port. Position yourself in the middle of the link. Point to switch A, point to switch D. Which way is shorter? If you go to A, then over to B, we have a cost of how much? 6. And if we go to D and then up to B, we have 4 plus 4, which is 8. 6 is less than 8. So we are pointing towards the shortest path, the shorter path. And that's through switch A, because the cost is only 6 going that way. So we can label that now as the designated port. So have we figured out all the root ports and designated ports? Well, we know where our root bridge is. We said we needed 3 root ports and we figured them out. And we said we needed how many designated ports? 6. 6 links, 6 designated ports. 1, 2, 3, 4, 5. Pardon me. 5 links. Where did I get 6 from? There's only 6 links. 1, 2, 3, 4, 5. 5 links. I'm confusing myself right now. So let's try that again. Designated ports. We said there was going to be 5 designated ports because there's 1 designated port per segment. We have 5 segments, 5 designated ports. Let's count them. 1, 2, 3, 4, 5. Much better. So we can't have any more designated ports. We can't have any more root ports, meaning everything else is blocked. So those 2 ports are blocked. Those 2 ports are blocked. And that's what prevents the loop within the layer 2 topology, by blocking those 2 ports.